an idea in my mind what is required, but it was very hazy. But when I explained it to Sushant, he was able to see that, okay, there has to be something really, and I think that the team did really well.
Hi, I'm 𝗖𝗲𝗱𝗃𝗀𝗃. I'm the co-founder of 𝗏𝗏𝗱𝗃 Studio, New Delhi. We're a design consultancy which has an expertise in doing computational design and parametric design, and we work across facades and art installation. This is a project I want to talk about where we have designed and executed a parametric facade for a global recruitment firm, Headfield, in Noida. This is located in sector 57 in Noida, and we were asked to create an iconic headquarters by uplifting and facelifting the facade. So when the clients approached us for this project, there had been a couple of iterations that the clients had tried to create an iconic language, and at one point they realized, okay, we need someone to really uplift the building in a unique and iconic way, which is where we got the opportunity to work on this project. The building that we got at the beginning, was already under construction. The architecture and the interiors of the building was already happening at that time, and we were brought in as parametric facade consultants on board to first design the project, and if we can, then possibly execute the project forward as well.
But most of the architects are not very innovative. They have a very set prototypes of how they design, and they can't read customer mind. The customer has to put a lot of efforts in explaining to the architect what they need, and still they fail. And that's why you see most of the architects doesn't have the best of the projects. How 𝗏𝗏𝗱𝗃 is winning awards all the time is because they get into the customer's mind, understand what they need. And this time 𝗏𝗏𝗃 had a challenge because the interiors that I've shown was out of the box. We were trying to make world's most innovative designs in the work interiors, commercial office interiors. We were able to strike designs interior-wise, but the facade we were, not being successful, and we had issues. My current architect were also not able to strike the designs, and even if there was a design, it was difficult to implement. Sometimes you get designs, but they are not really syncing with your whole idea.
So when we, when the site was given to us, the project was absolutely raw in the sense it was already under construction at that time. The interiors work was going on at that time, and we made a visit to the site. We looked around the context. So it's right across a prominent hotel, and it has a little green belt in front of it. If you look at the building location, so it's a very good location in terms of it had good views, and the building was very nicely and prominently visible from the main road as well. The buildings adjoining it, the context of the building was completely industrial, and a few commercial buildings which had a very typical, simple, conventional facades. So here it was the opportunity. The client also had a vision that, okay, I want this project to be the unique face of my building, of my brand, and what can we do in a cost-effective manner, something which always plays a bigger role, to create and uplift the building.
लेकिन the best part is the team understand the thing कि ये ज़रूरी है. ऐसा नहीं, they don't make any pressure कि हमें first time में ही कर दीजिए. तो which is really appreciable कि they understand the thing कि हमें कुछ steps प्रोटो के करने पड़ेंगे, तभी हम काम आगे बढ़ा पाएंगे.
We started with understanding the interior spaces, what was happening in the interiors, what exactly was being designed for the other areas as well, and tried to sort of draw some cues and inspiration. What drew our attention was there were a couple of arches and elliptical elements that were used in the interiors, and that really stuck to us that, okay, we have the interior space having a lot of arches as a transitional element. Can we try to use something of that kind in our project? Something that we went along later as well. The building had four windows, large windows and cutouts to sort of bring in light. The direction of the building was southwest, so it had a lot of sun coming in on the building, which would also mean a lot of radiation on the facade. So we had to sort of control that. There was a constraint that we could not get the facade completely to the ground. So whatever we were doing had to be sort of anchored onto this beam over here. And I think there were 2 or 3 beams on the entire facade which we could utilize and take the load off. And sort of play around in this canvas of 3-sided faces which anybody would see. The building extends a little deeper, but then you don't have the visibility of the rest of the area, so there was no point sort of doing the facade on that area as well. So this was sort of our canvas which we were presented with.
First design, we striked it. So we never looked at the other. There were 5 designs, but the first design, the first moment he was able to strike it, and it became a new logo of Headfield. So if you could see the invitation cards, everything, so it gives a new direction of how Headfield would. So my logo was not a logo, now the facade design became a new logo. So this was the power of a facade design.
So the first thought that we had was, which was sort of came from the client as well, that we want a sort of a corporate look, and glazing had to be used in some way or the other. So that was something which was a part of the brief. So we decided, why don't we just frame the entire building with a single glaze unit system, just as a screen with a laminated black color glass. So it sort of does not, you don't see what's happening inside. One, you get the views, you cut off the harsh sun and just convert that into diffuse light. At the same time, we would cover it with a skin, but the challenge was at how we can stop everything coming down to the ground because no supports were possible, no columns were coming onto the ground. Then the second aspect was the use of the arches. So arches was something that we were really trying. We tried a lot of options with pointed arch, semicircular arch, and asymmetric arches, and see what we can do with that. Eventually we ended up playing with the geometry where we had these arches, and which was sort of had these outer profiles going up. So this is pretty much like the reverse of a wine glass actually, and that's the shape of the facade. And in between there are intermediate members which was supposed to sort of cut off the light and act as solar blockers. So we had to ensure that the depth of these had to be sort of controlled so it's not cantilevered too much, yet it should protect from the sun and it should not block the views from inside. So factoring in all of these aspects, we typically look into sustainable principles when we design a facade. So solar radiation was an important aspect. So understanding how many kilowatt-hour per meter square of radiation is being received in the building. We did a quick analysis on the 3 faces that we were supposed to clad and understood the radiation values on different parts. We did the daylight analysis as a second thing, which is understanding the lux levels that we are receiving inside of the floor plates with the original 4 windows. Now, doing that, we realized there is a lot of glare coming in right behind these windows, and we looked at the functional zoning of the building, which made us realize, these are very important areas. These are actually manager cabins and CEO cabins right behind the building. So smaller rooms, so that will heat up quite a lot. So we had to ensure that we cover these with some sort of a fence. So that sort of defined our language.
अगेन फिर जब उसके ऊपर हम लोगों को ACP क्लैड करनी थी, तो जो कर्व एरियाज में हमने ACP क्लैड्स करी, लाइक दिस एरिया जो हमने ACP से हमने जो क्लैड किए, इस कर्व एरिया में अगेन ACP का जो फिक्सेशन और क्लोजिंग डिटेल थी विच इज़ वेरी चैलेंजेस। तो उसमें हम दिन भर में मुश्किल से 1 शीट का भी काम नहीं कर पाते, जहाँ पे लोग एक दिन में 10-10 या 20-20 शीट्स का फैब्रिकेट कर लेते हैं। यहाँ पे हम एक दिन का 1 शीट का भी आउटपुट नहीं निकाल पा रहे थे। बट जब एक बार शुरू हुए तो लेट देम फिनिश और बहुत अच्छा रहा। बट सबसे ज़्यादा खुशी की बात ये रही और जो मोटिवेशन और इंस्पिरेशन रहा कि जैसा डिज़ाइन है हमें वैसा जाना है, हम उससे डाइवर्ट नहीं हो सकते थे, चाहे हम उसमें कितने ही एफर्ट करने पड़े। और इस थॉट के साथ ही मुझे लगता है कि जो हम आज देख रहे हैं वो उसी थॉट की वजह से आ पाया है। आइदर अगर हम थोड़ा सा भी कॉम्प्रोमाइज करने के लिए सोचते तो ये ऐसा प्रोजेक्ट है कि हम थोड़ा सा भी डाइवर्ट होते तो ये हम अगर 1 डिग्री डाइवर्ट होते तो ये 20, 50, 30% तक डाइवर्ट हो जाता। तो आई थिंक परसिस्टेंस ऑन द प्रोजेक्ट की व्हाट वी रिक्वायर्ड विच इज मोर इम्पोर्टेंट।
Now, what we actually ended up designing looks like this. So we had the main arches, which is giving sort of a stone finish. When I say stone finish, we actually had to do everything in metal. But to use the finish, we obviously utilized different kind of finishes, which we can get in different textures. And while shortlisting and finalizing that, we ended up using something very simple, so that there will be elements which cannot be cladded with ACP, could be also matched in terms of the color and grade. So we ended up using the 𝗲𝗪𝗱𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀 and you basically have a glass skin, then you have ACP cladding, then you have these intermediate members which are MS tubes, and these tubes are bending like this as per the curvature because they are tweening between these two curves, and the cross section of this entire building, or you look at the ACP, is pretty much like this. So you have these offsetted geometry which had to have lighting inside it. So the detailing of that had to be done in a certain manner that you see a light going and creating and accentuating the geometry, and you have a lighting going over here. This profile of the arch was made through an aluminium tube. So a typical aluminium tube was actually cut into parts as half cuts and then bent to give a curvature. So we gave the curvature as the base using the aluminium tubes, which was covered with ACP. So aluminium tubes made the whole structure. Then it was covered with ACP. We had an MS structure behind which was sort of holding the glass on over here, which also takes the load of the entire facade. And then you have the aluminium section of the glazing unit, which is also taking the loads and the supports on the facade.
The design that is given by RATLabs, I was because they gave the concept and the whole the design formula and all. But I was also not very confident giving this design to be implemented by other companies because they could be because it's such a beautiful design, and the person who designed it, I really wanted him to implement it because he had an emotion towards the design. So I think the pricings were also reasonable. They were not really expensive because we checked with other vendors, and because my team cross-checked with other architects and other companies that could implement this design. Eventually we gave it to RATLabs, and it took 1 or 2 months extra, but I think we finally achieved what we needed, and then it won awards.
So there is a lot of structural work happening. We had to do a lot of wind analysis, structural studies. Our engineering team looked into value engineering the facade in a manner that the weight does not transmit too much onto this beam and gets evenly distributed. At the same time, it could be we could have this folding of MS happening like this right over here. When we have to look into the value engineering, we have to look into the fine-tuned detailing. We have to look at the loading of the facade onto the structure. So we have to make sure that, okay, this is my building cross-section. These are my intermediate members, which are sort of holding the facade. We could only give this support only where we had a beam present, basically, which was very limited. So we had to make sure that most of the load is coming onto these two beams and then this third beam. And this is the load that is the building is horizontally putting on the facade is horizontally putting onto the facade, and the vertical load that is coming down is basically on this canopy, which is made out of an MS truss. So you have an MS structure canopy which is anchored onto the beam that takes all the load, and the rest of the load goes on to this beam 1 and beam 2, and a bit of the load on the wall through another secondary anchor. And the critical parts of that are usually resolved when we do explore strategies like 3D printing. We did a lot of test models in a factory when we were executing this, but we also had to do a lot of 3D printing in the studio to have the facade 3D printed and understand where are the critical points, where are the junction points, and how we need to sort of take this forward into execution. So we made a lot of prototypes. Typically when we 3D print, we do a lot of prototyping at different scales, different levels, at different resolutions as well, which allows us to really imagine the facade at a 1:1 scale in a much more better and improvised manner. So something that we typically start with 3D renders to sort of showcase to the client. These 3D printed prototypes play a very critical role in the value engineering, because our engineering team is able to look into that, study that, analyze that. Our fabrication team is able to understand the critical points or what are the pain points and how we need to overcome that in the execution, and also allow us to plan the execution in a much more better manner.
जब मैंने 3D और रेंडर मेरे सामने आया फर्स्ट टाइम, आई से वाओ मज़ा आएगा, बट जैसे ही उसको स्टार्ट करने चले तो फेस चैलेंजेस. आई जस्ट शो द 3D मॉडल. व्हेन आई सी अबाउट दिस, इस कर्व को जब हम देखते हैं, ये कर्व ने सच में जान ले ली, बिकॉज दिस कर्व मेक्स नॉट इजी इन द मेटल. MS के साथ जाना था, इसमें कर्व्स लाइटिंग बननी थी, तो ये बहुत चैलेंजिंग था. इसमें 2-3 मॉड्यूल्स बना के उनको आपस में फैब्रिकेट और वेल्ड करके फिर वो प्रोफाइल बनाई गई.
Now talking about the mathematics and the geometry of it, we looked at this principle of tweening curves. Now tweening in geometry or mathematics is basically how something transitions from one geometry to the other. So if I transition or tween a straight line into a curved line like this, my tweens would be somewhat like this. So these are basically intermediate curve sections from A to B. So we use the same mathematical principle and logic over here, that we started with the arches, we had a boundary to the arch, and you had these two curves, so curve A and curve B, and then you did the tweening to get the intermediate language of these fins. Now while this was curving, we had to ensure that the curved part had to be limited so that it's easy to fabricate, it is quicker to fabricate, and it is cost effective. The central part, main arches, become the spine of the facade design.
So the main design, with giving a lighting, it's like a Dubai. Yeah. So the main is when we talk about the lighting that are implemented, where there's a full design, full lights. All the arches have lights, and sometimes we switch off the main arches and have the middle one arches having the light. So it has different ways to celebrate the success. If there is a festival, we can open all the arches lights. If it's a normal day, we can just use our basic the middle arches lights. So I think light also played a big role. The most beautiful facade looks in the night only with the light effects. It's like how Dubai looks in the night.
So when we talk of the lighting, how lighting played an integral role, as I explained, you have this one type of light, which is the lighting A, then you have the covered one, which is B, then you have the intermediate lights, which accentuate the geometry, which is C, and then you have the uplighters, which are at the intersections or where the touchdown happens at this level. So that is the lighting D. And what we ended up doing was sort of circuiting all of the lights separately, and making sort of a system on the side that we can either use only A, or A is supposed to be used with C, or A plus B plus C, or B plus C plus D, etc. So accordingly, we made, I think, about 8 combinations of lights, out of which 2 are really prominent ones, which we wanted to be used. And the intermediate lights that we had could be also used in a festive time, or where the facade really wants to create a more cinematic effect as a facade as a language. So we instructed the clients to sort of use it like that. In combination, they all like fit together in a very harmonic sense. And so most of the lights are warm white color temperature, and then we had some light which are slightly more yellowish color temperature, a little more warmer than the others. So in combination, they sit really well, and when they are in isolation, lit up, it really creates a very different and unique effect. And I think this is my personal favorite lighting pattern, which accentuates the outer curves, and it is also throwing some sort of a diffuse light onto the intermediate tweening members that we have over here.
So it looks like when any person walks, is around this building, they're walking by the building, they get awestruck of, which company they think it's a hotel, it's some kind of a unique company. And I think in Noida, we can't see such designs right now. But this is a very cute design, very futuristic design, and it really gives an attitude to my company.
The lighting had to be very critical. The cross-section of the MS tubes, that are the intermediate members that you have, which we call as the tweening arches, they have a cross-section of somewhat like this. And there is a light inside, which sort of makes the entire profile glow. And this entire cross-section has to curve and bend. Now, it is very difficult to bend a cross-sectional profile, extruded profile like this without being cost-effective. So that became sort of a challenge for us as well. So what we did in our factory was to sort of customize each of these surfaces separately. So basically you had surface 1, 2, 3, 4, and 5. You had these 5 surfaces which was CNC cut separately, neatly welded out to put together to make this cross section, and that formed the curvature which we have over here, and that is sort of repeated. So you have a construction modularity happening, yet at the same time a customizing happening in the facade. And I think that sort of defines the morphology. We call this project the story of the tweening arches, which is pretty much what it is about. You have these arches which are sort of tweening to create this design language. The end product was very simple and elegant, stands tall as an iconic project.
Even if you look at our invitation cards of that, it is a very unique one. So normally you don't see such invitation cards also, which was influenced by the facade design.
And now when everything is sort of done, we had the inauguration of the project recently done. This project has sort of become the icon for the brand, because it has not only become the face of the building, but also it is become a unique identity for the building. So I think all in all, we are pretty excited and happy with the output, in the sense we ended up creating a facade and design which we could execute in a very cost-effective manner, I would say, and giving a very rich and unique look, and also creating an identity for the project. So I think whenever we design a facade, our whole aim is to not just look at the facade with all the technical aspects that we have to look into, but we also look at the narrative of the facade. What exactly is the project doing for the brand? What exactly is it doing for the building? Because that has to be standing for a very long time, and it has to create a value, it has to create an impact, and it has to serve the purpose in terms of functional purpose, it has to serve the purpose of being cost effective, it has to serve the purpose of being sustainable in terms of environmentally conscious, and at the same time create the unique aesthetic that we wanted to create. So all in all, I think this project is a testament to our team, which has worked day and night, I would say, to make this dream project into a reality.
Failing to know what they want, they should visit Trad-Labs. So if they know what they want, it can be implemented by normal architects. But if they have some design and they want to go to an extreme level of a design, emotion, and they want to be a game changer, in their industry in terms of the building around that area, then they should visit RATLabs. They should try it. I think that's why RATLab keeps getting awards all the time, because the team has an emotion towards its customers.